20 valid parentheses. So in this problem, we're given a string that contains characters of opening and closing braces and brackets and parentheses. Now, we must return a boolean and will return true if the opening brackets are closed by the same type of brackets. And the brackets must be closed in correct order, and every closed bracket has a corresponding opening bracket of the same type. So looking through their examples, this string of an opening and closing parentheses is true because they are matching. And in this example, we have various types of parentheses, brackets, and braces that have their closing matching partner, so we'll return true. And in this example, we have an open parentheses and a closing bracket, thus we'll return false because they are not matching. Now, to explain my approach before diving into specifics of code, what I did was I used a stack, and when I came across an opening bracket, I would push it into the stack, and once I reached a closing bracket, I'd be able to compare the top of this stack with that current closing bracket, and if they don't match, we can instantly return false. Otherwise, we'll return true. And now, to get into the specifics of the code, first thing I did was instantiate a new stack, and now we're going to iterate through the string. I turned the string into an array of characters with this method here, and used a for each loop to iterate through each given character. And the first thing I did was I checked if the character is some type of opening bracket, we can push it to the stack. Now, once we reached a closing bracket like here, we're going to check if the stack is empty or not. Because if we're at a closing bracket and the stack is empty, that means there was never a preceding opening bracket before that. Thus, it's going to be an invalid parentheses. Otherwise, if this stack does have elements, we'll pop the top of that stack to return and remove that element. And if the top of that stack does not match the current element that we are iterating at, looking at, then we'll return false because we don't have a matching element. Thus, it's invalid. However, if we do have a matching element, we can keep on iterating through this string, and if we iterate through this entire string without returning false, that means we'll return stack.isEmpty. Stack.isEmpty will return true if the stack is empty and has no elements inside of it, but it will return false if the stack does have elements inside of it. Now, if the stack is empty, that means all of the opening brackets that were inside of that given string have been closed and had a partner. So it'll return true, which means it was valid parentheses. However, if there are unmatched opening brackets still in the stack, and we've iterated through the entire string, we'll return false. This allows us to account for edge case where we have a string with only one character. Because if we have a string with only one character, that means we're going to iterate through that string, and in this case, we have one opening parentheses, and so if C equals one opening parentheses, we will push it into the stack. However, if we have only one character, we cannot continue iterating through the string, thus this entire block of code below will never be reached. And since we just pushed that character into the stack, and this code cannot be reached because we're done iterating, we're going to return is stack empty or not. And since stack contains that singular character, stack is not empty, and it will return false. And so that helps us account for that edge case of only having one character. Now, another edge case to consider is when we have a string with non-sequential order brackets that do match, such as this, where we have matching braces that are enclosed on matching parentheses. And in this LeetCode problem, this is a valid case that will return true. And to kind of break this part down into code, this brace in this parentheses will successfully get pushed into the stack, and this parentheses will be on the top of the stack, and once we iterate, we'll reach this closing parentheses, and we'll compare this closing parentheses with the top of the stack, which is the opening parentheses, and those are a match. So we'll keep on iterating. Now remember, we did remove this from the stack. However, this opening brace is still in the stack. This is the new top of the stack technically. And so once we iterate and reach the end, and we reach that closing brace, we'll compare that closing brace with the top of the stack, which is this opening brace, and they are the same type of brace. Thus, we will not return false, and we've reached the end of the for each loop, and we have popped this top. Thus, the stack is empty, so when we return stack.isEmpty, it will return true. And that means this was a valid parentheses. Now, to get into the time complexity, it would be O of n, because as the input data increases, the time of operation is going to increase relative to the size of the input data. So if the string is, a huge string, that means the time of operation is going to increase in linear time in comparison to the increased size. And when we submit this, we see that it's accepted. I pass all the test cases, and I beat 98.61% of users in Java on this problem in my terms of runtime.